Dear students, welcome to the virtual class of Transform Calculus, Fourier Series and Numerical Techniques with the course code 18MAT31. This VTU 2018 scheme course will enable students to have an insight into Fourier series, Fourier transforms, Laplace transforms, difference equations and Z transform. Also, this will enable students to develop the proficiency in variational calculus and solving ODEs arising in engineering applications using numerical methods. Students, today we start with the module 1, Laplace transforms. On completion of this course, students are able to use Laplace transform and inverse Laplace transform in solving differential or integral equations arising in network analysis, control systems and other fields of engineering. Now let us know a little bit about the person who contributed or rather pioneered this concept, Pierre Simon Laplace. He was a French mathematician and astronomer of the 18th century, referred as Newton of France. He developed mathematics in astronomy, physics and statistics. His early published work started with the calculus and differential equation, which led later to Laplace transform. He spent many of his later years developing ideas about the movements of planets and the stability of the solar system, which is known as celestial mechanics, that is a branch of astronomy. So he focused more on this celestial mechanics. He is one of the first scientists to suggest the existence of dark holes, and also he was one of only 72 people to have his name engraved on the Eiffel Tower. Now let us move on to Laplace transform. What exactly this Laplace transform is? Laplace transform is a linear operator that switches a function of single variable t, time variant, f of t, into a lower order function of space, f of s. Or specifically, we can say it is an integral transform which converts a specific form of integration into merely an algebraic process. So here we go, the definition is L of f of t, where f of t is a function of single variable t defined for positive values of t, is a integral 0 to infinity, where 0 to infinity is a standard integral, definite integral. So integral 0 to infinity f of t into e power minus st dt, where e power minus st is known function, a standard function, is also known as a kernel of a Laplace transform. So obviously, as we integrate this, it gives a function of s. So Laplace transform of f of t is nothing but finally a function of s. That's what we said now in the beginning. It is a function f of t into a lower order function of f of s, a function s. So it makes sense that here f of t must be at least piecewise continuous for t greater than or equal to 0. And also we can say f of t and f of s form a transform pair. That is, if I know f of s, I can convert back to f of t, that is equivalently L inverse of f of s equal to f of t, where L inverse is nothing but inverse Laplace transform. So why we use Laplace transform? This is a basic tool for continuous time, that's convert time domain functions and operations into frequency domain, and also this is used as a tool to find solutions to differential equation with initial conditions. In the previous semester you might have come across solving linear differential equations where the general solution is yc plus yp, particular integral as well as complementary function we have to find. So but here by using Laplace transform we can solve a differential equation having initial conditions immediately just by applying Laplace transform technique. So what are the real life applications? If I note down some of them, we can say semiconductor mobility, call completion in wireless networks, vehicle vibrations on compressed rails, behavior of magnetic and electric fields above the atmosphere. So f of s is nothing but f of t. So I can now apply for some basic or elementary function and I can get the Laplace transform, but these results only required. It's not necessary we have to integrate and get it back, but I apply that for some simple functions. So let us take f of t equal to 1. So when f of t is 1, how to get the Laplace transform? The Laplace transform of f of t is nothing but Laplace transform of 1 means just apply the same definition, integrate with respect to t by multiplying this function along with e power minus st. So that means I can write L of 1 is equal to integral 1 into e power minus st, integrate between the standard limit 0 to infinity. So simple integral e power minus st by minus s, apply upper limit minus lower limit, which gives 1 by s where s is greater than 0. So the second one more I take exponential function f of t is e power at for t greater than or equal to 0. Now if I apply Laplace transform, again e power at you have to multiply with the e power minus st, correct? No, and the limit should be 0 to infinity. How to integrate this? As you know, a power m into a power n, indices law, a power m plus n. So I can write e power minus st into e power at is e power minus of s minus at. So integral of e power minus of s minus at is e power minus of s minus at by minus of s minus a, apply upper limit minus lower limit, when infinity e power minus infinity is 0, lower limit e power 0 that is 1, so we have outside minus, so minus of minus 1 by s minus a, so it gives 1 over s minus a. So I have taken one or two examples how we can get actually the Laplace transform by applying the definition, but here afterwards we take all those results directly which further we can apply while solving problems. So we have taken one more t power n, so Laplace transform of t power n, so I have written directly. So for exam point of view also this is enough, so we can take the results directly and we apply that whenever we require. So Laplace transform of t power n is gamma of n plus 1 by s power n plus 1, where gamma function you know in the previous semester you have taken that. For positive integer n, gamma of n plus 1 can be written as n factorial. So that's why Laplace transform of t power n is n factorial by s power n plus 1. For example, if I want to take Laplace transform of 1, which you have already taken in the previous slide, it is 1 by s, but I can apply directly from this result. So t power 0, that means 1. So where n is 0 now, what is the result? 0 factorial by s power n plus 1. So 0 factorial is 1 and s power 0 plus 1, that is s. So Laplace transform 1 is 1 by s. Next, if I want t, what is Laplace transform of t? That is t power 1. So n is 1, substitute 1 factorial by s power 1 plus 1, s square. T power 4, likewise it gives 4 factorial by s power 5. If I take exponential at e power at, the result we know 1 over s minus a, already we have derived it, but directly you can use this result wherever it is required. So e power minus at, so identify the coefficient of t, that's all. So what is coefficient of t here? In this case it is minus a, 1 over s minus of minus. In this if I substitute I'll get 1 over s plus a, correct? Example if you want you can take e power 3t, so a is 3, 1 over s minus 3. E power minus 2t, so what is a? Minus 2, 1 over s minus of minus 2, so that is s plus 2. So I move on to the next result. Take trigonometric function. So sin 80 result is a by s square plus a square, remember it. Cos 80 is s by s square plus a square. So just you have to identify the multiplicity. Sine and cosine function here, a multiple of a with the multiplicity a. So sin 80 is a by s square plus a square, cos 80 is s by s square plus a square. Thereby if I want sin 2t, what is a? A is here 2. So I have, that's why it is 2 by s square plus 4. So what is multiplicity of cos t here? That is 1. That's why it is s by s square plus a square. So the next result is hyperbolic. Sin hyperbolic 80 is what? A by s square minus a square. Students, here we can compare with the trigonometric function. Sin 80 is a by s square plus a square. Sin hyperbolic is a by s square minus a square. So only the difference in the denominator. So trigonometric it is plus s square plus a square. Here it's replaced by minus sign. So means I hope you can now guess cos hyperbolic 80. What should be the cos hyperbolic 80 result? It is s by s square minus a square. So two more results or examples. If I want sin hyperbolic 2t, I can substitute directly by identifying a is 2, now 2 by s square minus 4. Cos hyperbolic 3t is 3 by s square minus 9. So I have these results in my hand. Now I can take some problems. We just take some simple problems, and obviously they won't ask the problems directly. So whatever the problems they give, you have to first simplify by using your previous semester or previous level techniques. So might be it is trigonometric rules, trigonometric identities, formulas or algebraic expressions, logarithmic rules, etc, etc. So we have to first simplify into standard form, that is the form which the Laplace transform we have, Laplace transform of elementary function. So I have the first problem, Laplace transform of cos square 4t, not cos 4t, cos square. That's why you have to first simplify. If it is cos 4t, I can write directly, but cos square I have to simplify. And cos square theta formula, you know that. What is cos square theta? Here we get cos square theta 1 by 2 times 1 plus cos 2 theta, thereby cos square 4t 1 by 2 times 1 plus cos 2 into 4, that is 8t. So that's why Laplace transform of 1 plus cos 8t by 2 is nothing but cos square 4t. So Laplace transform of cos square 4t is 1 by 2 is anyhow constant, you can take it out. Laplace transform of 1 plus cos 8t. So I need these results now. So Laplace transform of 1 plus cos 8t I can split up because it satisfies the linearity property. L of 1 plus L of cos 8t, split term by term, you can write the results. So I have these results. Earlier we have taken L of 1 is a standard result, 1 by s, as well as cos 8t we know s by s square plus a square. That's why we get L of 1 by s plus L of cos 8t becomes s by s square plus 64. So cos square 4t Laplace transform we get by using this technique. Next, one more we have here, sin 2t cos 3t. So how to do that? So linearity property holds, but Laplace transform of product we cannot split. So remember that. So sin 2t plus cos 3t, if suppose we had, we can separately write term by term, but it is product. So unless you simplify, you cannot write the Laplace transform. Remember, so sin a cos b or cos a sin b result, you have anyhow product rule. Substitute, recall that results. What is cos a sin b? Half times sin a plus b minus sin a minus b. So that's why sin 2t into cos 3t, or I can read it as cos 3t into sin 2t. So which thereby gives half times Laplace transform of sin a plus b, that is 3 plus 2 is 5t, minus sin 3 minus 2, that is 1t, sin t. So I need sin a t result, which we know earlier we have taken a by s square plus a square. Replace a by 5 in the first case, a by 1 in the second term. It is 1 by 2 times 5 by s square plus 25 minus 1 over s square plus 1. Shall we move on to the next now? Last one more we take. Find the Laplace transform of 2t plus 3 the whole square. How we can get the Laplace transform here? So we have to just expand this by using the formula a plus b the whole square, a square plus 2ab plus b square. So which in turn gives now 4t square plus 12t plus 9. So term by term we have to apply the Laplace transform. For this we need the result t power n. So Laplace transform of t power n is n factorial by s power n plus 1. So that means 4 into Laplace transform of t square, 12 into Laplace transform of t, plus 9 into L of 1, Laplace transform of 1. Substitute this, we get 8 by s cube plus 12 by s square plus 9 by s, because 4 into L of t square is 2 factorial by s power 2 plus 1, so 2 by s cube. Outside I had 4, that's why it is 8 by s cube. Likewise you can take for the second and third term. Now along with these elementary functions Laplace transform, we can build some rules. There are some rules, so I can take the rule number 1, which says Laplace transform of e power at into f of t. So whenever it is a product of exponential into any function, how to get the Laplace transform? It is very simple. First obtain the Laplace transform of associated function. Once you get that, because f of t we can either get directly by using the standard result, or you can simplify as we have discussed in the last previous problem. Simplify this, and once it is reduced to the standard format, you can get the Laplace transform. But the result says whenever it is multiplied by e power at or a product of e power at into f of t, replace the answer which we get. It is obviously a function of s, so replace that s by s minus a. So what about e power minus at into f of t then? So replace s by s minus of minus a. So I have to replace s by, identify here coefficient of t is minus a. So s is replaced by s plus a. So this is very important. Correct? So I can go for some problems, you can understand that better. So sin 3t into exponential e power 2t. So here obviously I have to take sin 3t Laplace transform associated function first. Once the result is obtained, replace s by s minus 2. So what is sin 3t Laplace transform? You know that 3 by s square plus 9, but you have to now replace s by s minus 2, which gives 3 by s minus 2 the whole square plus 9. So Laplace transform of e power 2t sin 3t gives 3 by s minus 2 the whole square plus 9. So let us move to the next problem, that is t cube into e power minus 2t. So again here it is a product with the exponential into any function. So I have to first take the associated function t cube answer, Laplace transform of t cube. So what is Laplace transform of t cube? Then replace s by s plus 2. So I have Laplace transform of t cube is 3 factorial, that is 6 by s power 4. Replace s by s plus 2 gives 3 s by s plus 2 means 6 by s plus 2 power 4. Take one more, e power minus t into sin square t. Remember the associated function is sin square t. First get the Laplace transform of sin square t. Once the result is obtained, then go for replace s by s plus 1, because it is a is here minus 1, s minus minus s plus 1. But we can't get sin square t directly, but simplify first by applying the result. Sin square theta is half into 1 minus cos 2 theta. So that's why Laplace transform of 1 minus cos 2t. Once we get the result, we can go for substituting s by s plus 1. So the result is half times L of 1 by s minus s by s square plus 4. After substituting s by s plus 1, we get half into 1 by s plus 1 minus s plus 1 by s plus 1 square plus 4. Okay, so we take the next rule number 2, that says Laplace transform of t into f of t is minus d by ds of Laplace transform of f of t. So what to do now? Whenever it is product of t into any function, or t square into any function, t cube into any function, or in general t power n into any function. Earlier it is exponential into any function, now it is t power n into any function. Okay. The result says you have to first get the Laplace transform of associated function. So what is the associated function here? It is f of t. Get the Laplace transform of f of t, that is anyhow f of s, function of s. and differentiate once, t power 1, depending on that, differentiate once. If it is t power n, you have to differentiate n times and multiply that with the sign minus or plus, depending on minus 1 power n. So if it is t power 1 minus 1 power, so minus 1 power n d by ds, nth derivative of Laplace transform of f of t. If it is t square f of t, then Laplace transform how we can get? So we have to differentiate Laplace transform of f of t twice, d square by ds square, and multiply with the plus sign because minus 1 square. So let us take one or two results, problems. So t sin at, I want Laplace transform of t sin at. So associated function is sin at. So here I want to take sin at result, Laplace transform of sin at. So once it is obtained, you differentiate once and then multiply or take minus sign because minus 1 power 1. So that gives a by a square plus a square, differentiate d by ds of. So how to differentiate it? Either you can differentiate directly or you can use the quotient rule also, u by v rule, that is denominator square v square, denominator into derivative of numerator vu dash minus numerator into derivative of denominator. So I can get that result, denominator square s square plus a square the whole square, s square plus a square into derivative of numerator is a constant that gives 0 minus a into derivative of denominator 2s, so minus 2s into a, outside I have minus, so take inside, this gives 2as by s square plus a square the whole square. So let us take one more problem, t cos 2t. So Laplace transform of t into cos 2t, so associated function is here cos 2t. So replace, obtain the result Laplace transform of cos 2t by applying cos at result s by s square plus a square. Then once it is obtained, differentiate once by multiplying minus sign. So I get d by ds of s by s square plus 4 with the minus sign. Quotient rule again you can apply, u by v. So I get denominator s square plus 4 the whole square and denominator into derivative of numerator s square plus 4 into 1 minus s into 2s, that is minus 2s square. So if I simplify numerator, s square minus 2s square gives minus s square plus 4, but outside I have minus, so I can write s square minus 4 by s square plus 4 the whole square. So t square sin at, here we have t square. Since we have t square, what to do now? Sin at result you have to differentiate twice. So d square by ds square, Laplace transform of sin at is a by s square plus a square with minus 1 power n, n is here 2, that's why it is minus 1 square plus sign. So the sign is plus only, no need to change. So derivative of once derivative is minus 2as by s square plus a square the whole square. Again differentiate, denominator square again s square plus a square the power 4 minus 2as into denominator s square plus a square the whole square into derivative of numerator minus 2a minus of minus 2as, that is plus 2as into derivative of denominator 2 times s square plus a square into inner term, that is s square plus a square derivative is 2s, that's why it is 2s into 2as into 2s square plus a square. So this we can simplify further by taking, the best method is by taking common coefficients in the numerator. The common coefficient or common term is s square plus a square. Here s square plus a square the whole square, take it out. So 1 s square plus a square cancels with the denominator power 4, leaves back s square plus a square the whole cube. So numerator at least simplified with the s square plus a square removing. So final what we get is 6a square minus 2a cube, just check it. Numerator now gives 6a square minus 2a cube by s square plus a square the power 3. The last one more rule we have is division. So I have f of t by t. So we just taken Laplace transform of multiple t into f of t. So t into f of t is what? Once you get the Laplace transform of associated function f of t, differentiate it. Correct? No. So we can have a comparison or we can have a link. So once it is divide by t, we have to take integral. Remember likewise. So t into f of t minus d by ds of Laplace transform of f of t. So here associated function numerator is f of t. So take the Laplace transform, that is anyhow function of s. So integrate with respect to s, but remember this limit. The limit is s to infinity. So you have to integrate between the limit s to infinity. So simple, we can adopt this for the problems like division sin a t by t. So Laplace transform of sin a t, once I get the result, I can integrate between the limit s to infinity. So a by s square plus a square, what we have to integrate with respect to s between the limit s to infinity. So how to integrate this? I hope you have a formula, 1 by x square plus a square integral. You know that it is 1 by a tan inverse x by a. So since it is a is constant, so we have a into 1 by a anyhow cancel. So tan inverse s by a, apply the limit, upper limit minus lower limit. When s is infinity, we have tan inverse infinity. So tan inverse infinity is pi by 2 minus tan inverse s by a, but pi by 2 minus tan inverse s by a is cot inverse s by a. We know the result, pi by 2 minus tan inverse theta is cot inverse theta. So let me take one more, cos a t minus cos b t by t. Again the same rule we have to apply. Sin Laplace transform of cos a t minus cos b t. Once you get that, integrate it between the limit s to infinity. So here we have s by s square plus a square minus s by s square plus b square. So Laplace transform of integral of s by s square plus a square. How we can get integral of s by s square plus a square? That is log of root s square plus a square. Either you can go for substitution method or you can directly have a formula. It is f of x by f dash of x. Whenever denominator is f dash of x and direct derivative, f of x, f dash of x by f of x, 1 over f of x into f dash of x. So direct derivative of denominator in the numerator. So here we have a s square plus a square, its direct derivative is 2s. So you can multiply 2 and divide by 2, half times 2s by s square plus a square. So log of s square plus a square, but outside I have half, so it is half log s square plus a square, n log m, you know that, log m power n, that's why it is log root s square plus a square. So I have just applied that result. So I have log s square root s square plus a square minus log root s square plus b square, but we know that log a minus log b can be written as log a by b. That's why I have log root s square plus a square by s square plus b square. Now I apply the limit s to infinity, upper limit infinity. If I apply directly the limit, I'll get infinity plus a square is infinity. So first you simplify s square by taking common s square taken out, 1 plus a square by s square, then apply infinity, allow s tends to infinity. So a square by infinity is 0 because anything by infinity is 0, leaves back 1 plus 0, 1, 1 by 1, denominator also same thing happens. So it is 1, log 1 is anyhow it is 0. But minus, when we apply denominator, lower limit, it will be same, nothing will change, log root s square plus a square by s square plus b square. But again we have minus log root s square plus a square by s square plus b square. By applying the rule of logarithm, it is n log m is log m by n, log m power n, so that gives log root of s square plus b square by s square plus a square. So take one more last problem. So I just take e power a t minus e power b t by t, the same technique, integrate. After getting the Laplace transform of numerator, the result is here, 1 over s minus a minus 1 over s minus b. Integrate this with respect to s between the limit s to infinity. So since we know the answer, 1 over s minus a can be written as log of s minus a integral. So and adopt this rule also, logarithmic rule. So combining that, we get log of s minus a by s minus b, and then apply the limit s to infinity. Again the same situation arises. 0 minus log a by b can be written as log b by a, so that's why it is log of s minus b by s minus a. So student, we have taken all the basic Laplace transform, that means the Laplace transform of basic functions, along with the three results, three rules we have taken. So overall we can have a glance on that. So this is what you have to remember. So just have all these results when you are going to solve Laplace transform of any given function. Thank you for listening, and here are some problems for your practice. Just take all these problems, try to solve by using the results or the concept what we have taken today.